So the topic of today's lesson is centripetal force and centrifugal force. These two forces describe objects that are going in circular motion. Now, centripetal forces and centrifugal forces are two very important topics to master for the MCAT. They're very confusing. There's a lot of equations that we can relate to these, and students generally have a really hard time with these types of problems because we're dealing with angular motion. In angular motion, whenever we start spinning, whenever we start moving in a repetitive motion over and over again, things get a little bit more confusing. So for that reason, the MCAT loves to test on centripetal forces, centrifugal forces, and all kinds of angular motion problems. So make sure that you are very comfortable with the subjects we're about to talk about. In this segment, I'm going to talk about what these forces are, what we can use to calculate them, and what it means for one of them to be a real force, whereas the other one is a fictitious force. In following segments, we will talk about some ways that we can apply these forces, and I'll give you some practice problems to try out. So let's go ahead and use the example of a satellite orbiting the Earth. This is a very common example that will appear all the time on the MCAT. In this case, the satellite orbiting the Earth is constantly changing direction, which means it is changing velocity, which means it is experiencing an acceleration. And if it's experiencing acceleration, it must be experiencing that acceleration due to a force. In this case, that force is our centripetal force. Now, centripetal forces always point directly towards the center of their orbit. In this case, that would be this direction. So at any point on this circle, if we were to measure the centripetal force of the satellite at this point in its orbit, the centripetal force direction would still be pointed directly towards the center. Now, this applies to all kinds of circular motion problems. If we're talking about an electron orbiting a nucleus, if we're talking about a ball on a string being swung around someone's head, if we're talking about a roller coaster going around a loop, all of these things include centripetal forces. And likewise, they all include centrifugal forces, because centrifugal forces are the Newton's third law pair to centripetal forces. That means they are equal and opposite. So if our centripetal force is pointing straight in towards the center, then our centrifugal force is pointing in straight out away from the center. And they do have equal values, but they have opposite directions. So what's the equation that we can use in order to solve for centripetal force? The equation is F equals mv squared over r. Now, I'm sure that in your reading, you learned about how a centripetal force was a real force, whereas a centrifugal force was a fictitious force. What did that mean? So the reason why centripetal force is considered a real force, whereas centrifugal force is not, is because there's a real force that is causing our centripetal force. In this case, for example, of the satellite orbiting the Earth, our real force that is causing the satellite to orbit the Earth is a gravitational force, which in this case is g m1 m2 over r squared. If you don't know this equation already, that's okay. You will learn it very soon in the program, but just keep in mind that this is going to be an important equation to remember. So in this case, we have our centripetal force, which we can calculate using this equation, or we can calculate the centripetal force via the gravitational equation, simply because it's the gravitational force that is causing our centripetal force. Now, our centrifugal force, we can calculate the value using either of these two equations because, again, the value is equal and opposite to the centripetal force. But that doesn't mean that there is a gravitational force pulling it out this way, right? If we're in space, then that just doesn't make sense, right? There's nothing that's pulling it away from the Earth, right? The only reason why we talk about centrifugal forces is because it can sometimes feel like there's a centrifugal force. For example, have you ever been on one of those rides at an amusement park that spins really fast and causes you to kind of stick to the walls of the ride? I remember at the amusement park I went to, it was called Gravitron, and it would just spin super fast and got to the point where you could literally climb up on the walls and just get stuck there because it was spinning you to the wall so hard. And it really feels like there's some force pushing you into the wall, right? But there really isn't. There's nothing on top of you. There's no invisible forces acting on you. The only reason why you feel that way is because your body wants to continue going in a straight plane. But it's actually because of your centripetal force that's causing you to rotate towards the center constantly that you feel like this force is pushing you against the wall because your body wants to continue to go essentially into the wall. but it's the centripetal force that prevents that from happening, and that's why you appear to feel a centrifugal force, even though there really isn't a force that's causing you to feel that way. So keep that in mind. That's what it means when we talk about centripetal forces being real forces, whereas centrifugal forces are technically considered fictitious forces.